So the first step here is to successfully deploy app connectors in order to provide the secure authenticated interface between a customer's servers and the ZPA cloud. Now, app connectors, they can be deployed in several forms. Zscaler distributes a standard VM, virtual machine here, image that can be used in enterprise data centers. We have local private cloud environments such as VMware, or public cloud environments such as being able to support AWS EC2 with AMI. Additionally, Zscaler also provides packages that can be installed on supported Linux distributions. So many ways to deploy these application connectors themselves. And as you're thinking about how and where to deploy these application connectors, you might start and say, well, we'll just deploy them in our main data center, and everything will funnel into that data center and go across the internal network. But as you build out, for example, let's say you have a total of 5 data centers, it's important that you deploy applications in each of those data centers. It's important that each one is within a different app connector group as well, because Zscaler Private Access will select an app connector group to load balance connections across these app connectors within the group. And you really want to deploy these application connectors as close to those applications as possible as well. At a minimum, it's required that you deploy 2 app connectors to provide a degree of fault tolerance. This allows for failover, resiliency, such as when performing upgrades to the app connectors. When we schedule an upgrade to an app connector, we stop receiving connection requests for a period to ensure that no connections are dropped as the upgrade process begins. And then once the app connector begins the upgrade process, the other app connector handles the incoming connection requests. Now, when the upgrade of the first app connector is completed, the next app connector will begin its process, during which it will also stop receiving new connections, and then the latter app connector will handle all of the other incoming connection requests while it undergoes the upgrade. So having a single app connector in the data center, it's not effective, and it becomes a single point of failure. Now, we also need to ensure that the app connectors can resolve and route to the internet and your internal applications themselves. So it's imperative that your firewalls and policies to ensure that the necessary connectivity is actually being allowed, that it's established that way. So app connectors also need to be able to do health check to applications. So if you've got a web server on port 80, then the app connector will open a connection on port 80 to check that it's available by checking the path in the round time trip. If it's a UDP application, such as an RDP session, then it will infer that the application is available by a previous TCP health check that has occurred and said that the application is available. Or it will perform an ICMP request to check whether that application is available. So again, you want to ensure that TCP, UDP, ICMP is available to your applications from these app connectors. Now, finally, it's also important to realize that in a zero trust networking access environment, the client never gets the actual IP address of the application. The client is never placed onto the network as well, and the client never gets an IP address on that network. So we are entirely segmenting the user from the network. The source IP address of requests made to the application will always be the IP address of the application connector here. Now, this means services that rely on knowing the source IP, whether it be for routing or load balancing purposes, will not receive the IP address of the client. It is also critical that the IP addresses of the app connectors are registered with an Active Directory sites and services. Now, architecturally, your deployment may resemble something like the diagram seen here. We have infrastructure as a service via AWS, where our pair of app connectors are deployed within an app connector group. We see described here the TCP and ICMP health checks occurring between the app connectors and the applications ensuring their availability. And we have another app connector group deployed in Azure with a similar setup. Additionally, we have 2 interconnected physical data centers, for example, via MPLS, each with a pair of app connectors deployed in their respective app connector groups. Also represented are Direct Connect and Express Route connections bridging our physical data centers into our cloud platforms. So now this means that any of our app connectors can talk to the applications in any location. However, the app connectors will optimize the connections via their respective app connector groups, providing the end user with the best connection experience. Additionally, app connectors rely on what is called a provisioning key. Now, the provisioning key is generated from the console and dropped onto the app connectors, which enrolls the app connector into your tenant. Provisioning keys are generated and then signed by the intermediate certificate authority, and then clients also receive their certificates, which are signed by an intermediate CA. Ideally, you would want to leverage separate intermediate CAs for each of the different services within ZPA. Examples of these services include client connectors, application connectors, isolation profiles, web servers. This builds out your chain of trust, and by segmenting the services across separate intermediate CAs, you can revoke a set of certificates without impacting the functionality of other services. If you delete a provisioning key, then you will revoke all app connectors that were enrolled with said key. Now, if you revoke the intermediate CA, then all provisioning keys issued by the intermediate CA are revoked. This holds true for the clients as well with respect to their intermediate CA. It is important to design the trust hierarchy before implementing certificates and provisioning keys within ZPA. The provisioning keys can be thought of as credentials for enrollment into ZPA. They should be handled and kept secure in the same manner you would any type of secure access credential. That is to say, never send them in a clear text email.